Earth rotated much faster than it does today. About 1.4 billion years ago, Earth completed one full spin on its axis in just 18 hours. Today, that same rotation takes approximately 24 hours. This means ancient Earth was spinning around 33% faster than it does now. Imagine waking up at 6 o'clock in the morning and seeing the sun set by noon. Night would also pass much faster, and another sunrise would arrive only a few hours later. People, if they had existed, would experience more days in the same amount of time. The faster rotation also meant Earth had greater rotational speed at the equator, influencing atmospheric circulation, ocean movement, and climate in ways very different from today's world. The Moon has been acting like a giant brake for Earth for billions of years. The main reason Earth's rotation has slowed is the Moon's gravitational pull. The Moon's gravity pulls on Earth's oceans, creating tides. However, because Earth spins faster than the Moon orbits, these tidal bulges are pulled slightly ahead of the Moon. This creates friction between the oceans, the seafloor, and Earth's crust. That friction gradually steals a tiny amount of Earth's rotational energy, causing the planet to spin a little more slowly. Think of it like spinning a playground merry-go-round. If someone lightly drags their feet on the ground while riding it, the merry-go-round slowly loses speed. The Moon has been doing something similar to Earth for over 4.5 billion years. Energy doesn't disappear, it is transferred. The rotational energy Earth loses is passed to the Moon. As a result, the Moon slowly moves into a higher orbit around Earth. Today, the Moon is drifting away at a rate of about 3.8 centimeters, 1.5 inches every year. That may sound tiny, but over millions of years, it becomes enormous. In 1 million years, about 38 kilometers farther away. In 100 million years, about 3,800 kilometers farther away. Over billions of years, tens of thousands of kilometers farther from Earth. Scientists confirmed this by bouncing laser beams off mirrors placed on the Moon by Apollo astronauts and precisely measuring the return time. A year contained nearly 490 days. Earth still took almost the same amount of time to orbit the Sun, about 365 1/4 modern days. But because each day lasted only 18 hours, many more days fit into one orbit around the Sun. Instead of 365 days times 24 hours equals 8,760 hours, ancient Earth had approximately 490 days times 18 hours, approximately 8,820 hours. The total number of hours in a year stayed almost the same, but they were divided into shorter days. If calendars had existed then, birthdays would have come after nearly 490 sunrises, instead of 365. Scientists found evidence hidden inside ancient rocks. No one observed Earth 1.4 billion years ago. So how do scientists know? The answer lies in special rock formations called tidal rhythmites. These rocks formed in ancient coastal environments where ocean tides repeatedly deposited layers of sediment. Each tidal cycle left a tiny layer behind. By carefully counting and measuring these layers, scientists can determine how many tides occurred each day, how many days were in a month, how many days occurred in a year, and how quickly Earth rotated. Scientists also study growth rings in ancient corals and shell-forming organisms from later periods. Much like tree rings record years, these fossils preserve daily growth patterns that reveal how many days existed in a year millions of years ago. These natural records serve as Earth's own history books. A faster spinning Earth behaved differently. Because the planet rotated more rapidly, winds were stronger. Ocean currents followed different paths. The Coriolis effect, which causes hurricanes and global wind patterns, was stronger, and daytime heating and nighttime cooling happened more frequently. Instead of experiencing 12 hours of daylight and 12 hours of darkness near the equator, organisms experienced much shorter light and dark cycles. At that time, Earth was mostly inhabited by microscopic organisms, such as bacteria and algae. Their biological processes evolved under these unusual conditions. Some scientists believe Earth's faster rotation also influenced nutrient circulation in the oceans, affecting the evolution of early life. Shorter days changed the planet's climate and oceans. That is a critical insight for understanding Earth's history and the evolution of life. Earth's rotation is still slowing right now. The process hasn't stopped. Earth continues to lose rotational speed today. On average, each century makes Earth's day about 1.7 milliseconds longer. That means, after 100 years, a day is about 0.0017 seconds longer. After 10,000 years, about 0.17 seconds longer. After millions of years, the difference becomes significant. Because Earth's rotation is not perfectly constant, scientists use extremely accurate atomic clocks to measure time. Occasionally, global timekeeping systems require adjustments, so civil time stays synchronized with Earth's actual rotation. Earth's very distant future will look completely different. If nothing interrupted the process and enough time passed, Earth and the Moon would eventually become tidally locked. This means Earth would rotate once in exactly the same time the Moon completes one orbit. The same side of Earth would always face the Moon. The Moon would appear fixed in the sky instead of rising and setting. However, this would require tens of billions of years, far longer than the Sun is expected to remain a stable star. Long before tidal locking could occur, the Sun will evolve into a red giant, dramatically changing or even destroying Earth's current environment.